Hey, Vlad here, devinside.com. Welcome to another video. Ever since I made the video about the differences between objects and data structures, we have been concentrated rather on the data-oriented programming as opposed to the object-oriented programming, the topic to which we'll get back to in this video. Today we're going to talk about packages and imports, and even though they're technically not object-oriented concepts in other languages, in Scala they're implemented in such a way that it almost feels like they are. As always, we're in the Ubuntu virtual machine and we have Sublime on the left and the regular terminal on the right, which runs SBT, which runs our code every time we save the file. In the very beginning of this playlist, we learned about scopes and how they protect us from name collisions, right? So we started with a teeny tiny scope like this. And by the way, notice that there's a new Sublime version that came out recently. So my bracket highlighter plugin actually has colors now. So it marks parentheses with yellow and it marks the string quotes with green and so on. So remember, we started with like teeny tiny empty scopes, and then we learned that we can assign scopes to variables. Let me just type out a few examples. So we're going to have a potentially lazy val, right, like this, x equals 1, and now we can print line x, and we could have a different scope with a different x in there, right? So scopes, they protect us from name collisions, right? So we can have a it doesn't actually matter what it is. We can have a def x equals 2, right? Which is not a val, like this. And we could also have a var, for example, over here equals 3. So we have like a bunch of different ones. So we learned about scopes in sort of like a bottom-up fashion. We learned about vals, defs, vars, and even type aliases. And then later we learned about classes, objects, and traits, bigger concepts. Let me type them out as well. So for example, this one could be an object first, right? And this one, whoops, could be a class second, and this one could be a trait third, for example, right? So now we're not going to see the 1, 2, 3 because we're not calling anything on them, but still we can have name collisions, right? So because a class and object, they can be companions of each other, we could use first, for example, twice, and we could do the same thing for the trait, right? So this one could be also first, but this one has to be called second now, like this. Right, but you can't do class and the trait with the same name, so you can't do here. You can't do this. It's going to say second is already defined as class second. And we have seen how to mix and match them, and even how to override, one thing with another. For example, you can override a def with a val, or you can override a def with an object. You can nest them however you like, right? Like for example this, and the nesting could go like really crazy. For example, look at this. We have an object, and inside of it we have two defs. Inside of it we have an object. Inside of it we have a class, and then inside of it we have a def and the trait, and it has a var, and so on. So in production, like in real applications, usually you don't go crazy with nesting. I mean, at least good programmers don't do this, but still it's kind of cool to know that it is possible. In any case, this whole nesting is not entirely the topic of this conversation of this video. What we're going to do is we're going to create a new file. So I'm going to go to a folder where we have just the main. I'm going to create a file, and I'm going to call it nouns.scala, because the example that we're going to work with today is going to be about nouns. Look at what's going to happen if we're going to try to have an empty scope over here. It's going to say expected class or object definition. So even if we had a def over here, right, and we give it a name, like for example nouns, right, and we could have an equal sign as well, none of it is going to help. So we have to have at least a class or object or a trait, right? So let's start with an object nouns. There can't be an equal sign, right? So now all of a sudden it compiles, right? So what we're going to have in here, we're going to have flowers, just flowers, and let me duplicate that, and we're going to have dog. We're just going to have a bunch of nouns, right? We're going to have cat, gonna have a car, and we're gonna have a plane, like this. We're not gonna print them out or anything like that. The point is that if you keep going like this, there are like thousands of nouns in the English language, right? So if you keep going like this, the file is gonna get like really big. So what we're trying to figure out is how to split those out into multiple files. And the first idea that we'll have is well, first let's categorize them, right? So let's split them into, for example, plants. right? So we're gonna have plants, which is in this case just flowers, right? And now we're gonna have animals, right? Just let's move them into here, or here. And we're also gonna have, let's call it transport, like this. Right, so this helps a little bit, right? It looks kind of neat and it looks like a bit modular, but it actually doesn't solve our problem. So the question is, how can we take something like animals, for example, and take it out, right? So we could of course create another file called animals and just move this object into there, but then it's not going to be a part of nouns anymore. For now, let's just move it down, right? So now it's over here. Everything still compiles, but it's still, you know, it's not a part of nouns. So we already know that a file can contain an object. So I don't have to demonstrate that we can create another file called animals and put this in there. What I will demonstrate though is that if we try to do this, object nouns, right? Because, you know, if you sort of try to cheat, because okay, you know, we can put objects in files, right? So we could just take this thing and put it in a different file. The problem is that we can't have a name conflict over here, right? So this whole thing is considered one scope, and we can't have two objects with exactly the same name in one scope. And even if I put it in a different file, we still can't have it. I'm not going to demonstrate this, but I'm sure you understand what I mean. And this is where packages come in. A package is just a different keyword from objects. So instead of using objects here, so where we say object nouns, I'm just going to go here and we're going to say package instead. Right, and the convention for packages is to call them with a lowercase, right? So instead of nouns capital like this, we're just going to do nouns, right? And as you can already see, a package itself can be in a file, right? So in a file we can have an object, a trait, a class, and now we also know that we can have a package, right? What you should know is that this convenience, it comes at a price. What we can have inside of a package is the same thing, right? We can only have objects, classes, traits, and other packages as well, as we will see a bit later, right? So the next thing, actually let me show this to you. So if I try to have val x equals 10 over here, or 20, whatever, just typed it wrong, it's going to say expected class or object definition, and traits are also possible, but it doesn't say that. And also, again, you know, you could have other packages in here. There's actually a special feature in Scala that will help to mitigate this issue that we will see a bit later in the video. Also, notice that packages are highly optional, right? So if you're writing a small program, you don't actually need packages. We survived more than 20 videos without packages, okay? All right, so let's try to move packages, you know, into different files. So first, let me remove this, right? And let's also have a third one, right? So we're going to have package nouns, and we're going to move transport into there, like this, right? Like this. Let me remove all the spaces. Okay, so now we have like the same package and three different objects inside of them. So now we want to split them into different files. Well, how can we do this, right? So we can't have a file called nouns, even if it's lowercase, 3 times. So we use folders. We go over here and we create a new folder. We call it nouns, right? And inside of it, we're going to create 3 files, right? So we're going to create animals.scala. We're going to create also plants.scala, and we're also going to create transport, if I spell it right, transport.scala, like this, right? And Sublime allows me to do this, so I can have plants on this one. No, I can. Let's do it alphabetically. Let's do animals here, let's do plants over here, and let's do transport over here, right? So now I can go to nouns over here, right? I can just cut this out, put this into plants, for example. I can cut this out, put this into animals, for example, and I can cut this out and put it into transport. And now I'm going to start saving all of them, especially the nouns one that is empty now. We can remove the nouns, delete file. All right, so we have a folder nouns. Inside of it, we have 3 files: animals, plants, and transport, well, which you can see over here: animals, plants, and transport. And we also still have our main with this big example, which I actually don't need anymore. Let me get rid of it. Let me do a hello world over here. Hello world. Right, so we have animals, plants, nouns, and we have our hello world. And we also have some rendering issues from the VM. Like, come on. There we go, animals. Animals, plants, transport. Remember that in this entire playlist, I'm assuming that Scala is the very first programming language that you're learning. So from time to time, I'm going to compare it with other different languages so that you can get a bigger picture. For example, in Java, you wouldn't be allowed such great flexibility. You wouldn't be able to have different packages, it's the same package or even multiple different packages in the same file. In Java, a package name has to correspond to the folder name and it has to reside in this folder. The same thing for classes or interfaces. Interfaces are traits in Java. You would have to have the class or interface name correspond to the file name. So in Scala, you have a much bigger flexibility, so to say, which does not necessarily mean that you should abuse it. In fact, 83% of the time, which is a typical number that I use when I make up statistics, in production systems in Scala, you would use the Java's constraint as sort of like a guideline. So in fact, most of the times, you will have your packages aligned with the folders and you will have your classes aligned with the file names. You can access these things from the packages and from objects with the typical dot notation as we have learned before, right? So for example, over here, obviously we can say print line flowers. We only care about compiling right now, right? Because we like in our main, we're not saying, print line plants flowers, right? So if we had a different object over here, like for example, object blah, right? So if you wanted to access flowers, we would need to say plants dot flowers, or we would need to say, the whole thing. We would need to go to say the nouns dot plants dot flowers, right? So we're only caring about compiling, right? The same way, like even though it's in a different file, we can also go and say a print line transport dot car, because transport is in the same package like nouns. For now, let's go to main and let's try to do the same thing. So let's go to main and let's try to do nouns dot plants dot flower, right? So this is also called a fully qualified name. It's flowers, not flower, right? So this full notation, package and then an object and whatever is called the fully qualified name. And by the end of this video, we're going to learn about imports, which is a technique of how to shorten these lines, right? Because they have a tendency to get like really, really long, right? So also notice that we can do, nouns dot plants, but what we can't do is print out nouns, because nouns is not a value. Nouns is just a package, and packages are, they're a bit less primitive. They're not so-called first-class citizens in Scala, right? So you can't pass them around as data. All right, so let me remove that. And the next thing that we're going to learn is that you can have a package inside of a package, right? So for example, let's take this one and let's surround it with another package, words. So nouns are also words, right? So we can go here, go down like this. Let me actually make this one smaller and this one bigger so that you see the whole thing like this. And now let's move this one a bit to there, right? So now a bunch of things are not going to compile. For example, in plants 11, which is over here, we can't do transport.car anymore because now we're in words nouns and this package is just nouns, right? So over here, we would need to say nouns.transport.car, and this is still not going to work. It's actually kind of funny because we have a concept here called packages, which is supposed to protect us, against things like this, but somehow it drove us into a corner where we can't distinguish this package nouns from the package words.nouns. So if you wanted to say words.nouns, we obviously could, right? But how do we get access to this? Well, it turns out that Scala has a solution. Every package in Scala is automatically a sub package of a package called _root_, right? So over here we can say _root_ dot, right? So _root_ is just a name for a package, right? So you can imagine that it's like this, that it's over here, root_, right? And the whole nouns thing is inside of it, right? It's not going to compile like this, but this is how you can imagine it. Let me revert that. Come on, let's just revert that like this. If we save this, now this part is going to work, right? So this part is working now, but main is not working. It says object plants is not a member of package nouns. Well, we have to go to main and we have to do the same trick. Okay, let me see. Okay, so over here, we have to say, okay, we actually mean words.nouns. And the same here, words.nouns, right? So the fully qualified name, and now we can have sub packages. Even though it's possible to get access to everything through the _root_, this is not a good programming style. So what we should do is we should probably put them also into words, right? Put your thoughts into words like this. Let me make it a bit bigger so that you see everything. Okay, so we have package words nouns, and let's do the same thing with the animals. Right, package words like this, put it down like that, bring these to the right like this. And now let's fix the error. So now we don't need root over here. We can just do nouns, right? In fact, I believe we can also just do transport, right? Yeah, over here we can also just do transport. Now in main, everything is still fine. Okay, everything is still fine, right? So you know, just to give you an example of, you know, following Java's convention, we should probably also create a folder over here called words, right? And let me open the containing folder, and we can just go put all the nouns into words like this. And now Sublime is a bit confused, right? Because it thinks that, you know, the files are gone, so I have to close them all real quick except for main, right? So now I can open words, open nouns. We have animals over here, we have plants over here. Sorry, I have to double click it. Animals over here, plants over here, and transport over here, and everything still works the same as before. Now, what you should notice is that if we keep nesting packages like this, we're sort of going to run out of the horizontal space, right? And Scala has a syntactic trigger for that. So what we sort of want is we want to have it like this, and you know, obviously it's still going to compile, right? It's still going to compile, but you know, it's not a beautiful code. And sometimes we have plugins for SPT, for example, or for your editors that will format your code automatically, and they will never format your code like this. So what you can do is you can just remove those braces like this. Remove those braces, and it's going to compile now, right? So it's, you know, it's getting smaller, but it's still going to compile. And then you're just going to have a line over here and like this. So this is how you usually have this. It is also called chain package clauses, right? So there are a few things that you need to know about this. The first thing is be careful when having multiple packages in the same file, right? So if you're going to have a package words over here, right, and you're going to have an object hi over here, then this is actually words.nouns .words again .hi, right? So this is not going to have the same effect as you know, as we had before. So just basically never nest it like this. In production, this also never happens, right? Usually people either have this or something that I'm going to show you in a few seconds. The next thing that we're going to talk about are so-called package objects. Package objects are this technique that I mentioned a few minutes ago of how you can have vals and defs and type aliases and so on sort of on the level of the package. So what you can do is you can create an object over here, right? So it's going to be in words nouns, and you can call it package. Right, and because it's, you know, package is the keyword in the language, you have to surround it with backticks. Oh, I thought Sublime would do this for me. Okay, so if you have an object package like this, right? So let me save it. It's going to compile, right? Then inside of it, you can have you know, regular stuff. You can have, you know, a value. You can have, hold up, how are we going to do this? B value. You know, you can have a val. Let's also have a var, c. Just, you know, just to demonstrate that all of this is possible, right? So you can also have a lazy val, d, right, like this. It's a d value, and you can also have type aliases. You can have type e equals string, which is a horrible alias, by the way, right? So now if we go to main, right, where we have, you know, print out flowers and you know, plants and whatever, so what we can do is we can print out words.nouns in the same way as we access the object plants, right? This one, the same way we can, you know, we don't have to say dot package or something. We can go directly to a, right? So we can do a, right? Let me save this, and let me just type out the rest. So we're gonna have a b and a c and a d. And we can print out a type, but we can't do a print line, some string, right? And we can use a type description, so we can do string, right? But we can also do words.nouns.e. It's going to be exactly the same thing. Now, it is not common to have a package object defined somewhere like in the middle of nowhere. Usually, you would have a separate file. Let's create a file. You usually would call it also package.scala, right? And you would just take it out and put it in there. So I'm going to cut it out. I don't like those spaces, and we're gonna put it over here, right? So it has to be in the same package, right? So it has to be in package words, it has to be package nouns, right? So this is how you usually would have it, but you know, in fact, many people don't know it, that you can use this syntax. But what many people know is that instead of this, you can use a much nicer syntax like this. You can say package object nouns over here, right? And then you don't have to do this whole nonsense, right? So you can just, what I marked right now, you can remove all of it, right? And it's going to have exactly the same effect. So you're going to have a package words, and you're going to have a package object nouns. This is why they're also called package objects, by the way, and this is how it works. Unfortunately, you can have only one, right? So you can't have, you know, another package object defined somewhere else. What you should also know about this, that this is not entirely like a, you know, a proper object. For example, look, we can print out main over here, right? And we can also, a main also has a type, so we can do main dot, we can use a type description. We can do main dot type, right? But we can't do this with the nouns, right? So we can't do words that nouns, right? We can't do this, and also let me comment this out. Also, we can't do, we can't use the description, right? So we can't do words dot nouns dot type. So now we have one error, and then we're gonna have two errors. What you can do is you can, let me remove these. You can have a trait, right? So you can have a trait. You can call it, I don't know, you can use the capital nouns, for example, right? And you can put, I don't know, for example, all of this in there, right? And you can mix it in, right? You can extend nouns, right? And the same thing would work with an abstract class, right? So you can have an abstract class like this, right? So this is done for the reason that, if your package object gets like too large, you can still split it out in, in multiple traits, which is kind of cool. The next thing that we're going to talk about are access modifiers. I don't like this topic actually, and I don't want to go in depth into it. So basically, everything you define without a keyword is, it's publicly available. And everything you mark as private, it is private for the package. The same thing for protected. Protected and private, they don't have any difference on the if I spell it right, they don't have any significance on the for the top level object, right? So as you can see, we already can't access stuff, right? So it says main is not a subclass, blah blah blah. Here, access to protected object plans not permitted. Does it do the same thing for private? Yeah, it does, probably. Yeah, cannot be accessed, blah, blah, blah. Okay, so you also have those, much granular constraints. Like, for example, you can say, okay, it's private, but it's not private for nouns, it's private for words, for example, right? Like this. You can do the same thing over here, right? So you can say this is a private for, like usually if you would just do private, it will be private for plants, right? But you could do it private for nouns, for example, right? Or you can do it private for words. All of this is going to compile if I manage to spell it right. Okay, right. So I don't want to go in depth into this. In fact, let me remove this. So there are many reasons why I don't want to go in depth into this. First of all, it's kind of boring. Second of all, it's kind of hard to remember anyway. You rarely use such very fine granularity in production code. And fourth, like whenever you actually want to achieve something, you just play around with it for a minute, and you try to get it to compile. Or if you don't want some things to compile, you make sure that they don't compile, and that's it. But having said all that, I got a link for you. I'm gonna post it down in the description. Was a blog post where a guy called Jesper Dijon, I probably butchered his name. So he summed all of this up for you. So if you're really curious, it's also a comparison between Java and Scala. So you can read it. You get private top level types and all that stuff. It's a very, very small read. It's very concise. It's beautifully done. So I'm not going to go into depth into this. So let's get back to our code. The last thing about packages that we're going to learn today is before we go to imports, is that there's a different style of introducing packages, and it's actually coming more from Java, and it's more typical. So instead of saying package words and then package nouns, you could achieve the same results by saying package words dot nouns. However, you won't have direct access to the things that are in words now, right? So for example, over here it says, okay, where are we? Plan Scala 10, not found value nouns. So over here at 10, so nouns doesn't exist anymore, right? So because we are in project nouns, right? So we either have to do, we either have to remove it like this, right? Or we have to go to words.nouns, right? But we can't just use nouns, because nouns is not, not a, touchable thing anymore. All right, so let's talk about imports. So let's go back to main, and let me actually remove all of this like that. All right, so we have print line words, nouns, plants, flowers. So imports allow you to write all of this shorter, right? So they allow you to have a faster access to the insides of packages and objects and whatever. Now, usually imports are introduced together with packages, but in Scala, as you will see in a few minutes, the imports are not limited to packages. You can literally import everything. Let me show you. So first of all, for example, in a language like Java, you can have imports only at the top of the file. In Scala, you can have them literally anywhere. And it's a convention, though, to have them at least at the top of the scope. So for example, we have dev code over here. The first thing that should happen is the imports. So we can do import words.nouns.plants.flowers, right? Flowers. And now what I can do is, instead of this, I'm gonna leave it actually there. I can say print line flowers, right? So now this is exactly the same thing, and you can keep going and removing things, right? For example, if you need multiple things from plants, you can just import plants, right? So you can remove it from here. You can remove flowers from there, and now you can do plants.flowers, because now we're importing plants, and you can keep going like this, right? So you can remove plants from here. Now we're importing nouns, so now we can go over here. I hope it's very self-explanatory. We can't do the same thing with words, I believe. Yeah, we can't do the same thing with words because words is already a top level package, right? So this part is not going to compile, right? So first of all, let me go back and actually have the import at the top of the file, because this is like the typical way of having them, right? So let's import words.nouns.plants.flowers, right, like this. And let me remove this, right? And now we can have flowers again. And also let me minimize this whole thing, because I want you to see all the code. Doesn't really matter what's in transport and what's in plants right now, right? So what matters is plants, right? So we have this thing over here, and of course there's a typo. Let me remove that. All right, so what you also can do is you can import multiple things, right? So Jesus, what's happening, right? Plants like this. Okay, so what you can do is you can import multiple things. Like for example, instead of importing plants, flowers, in fact, I probably should have said it like this, right? So let's do this. Let's do plants.flowers. Okay. So let's say you don't only want plants, you also want plants and transport. So what you can do is you can surround it with curly braces, and you can do this. And sometimes you would see spaces over here. It's always different. Just agree on something with your team and follow that, right? So now we have plants and transport. So now we can also print line transport dot, I believe it's car or cars. I don't remember how to call it. Yeah, it's car, right? So, but we can't access, for example, from animals, right? So we can't do print line animals dot cat, right? So cat is not here, right? Sorry, animals is not here. But if we do animals over here, let me collapse this other thing so you see the whole code. The next thing, that if you have name collisions, for example, let's say you have a collision with transport, right? So let's say that you have a a val here called transport, and it's just some string, right? So now this is gonna this is not gonna work anymore. Let me remove animals real quick. I'm sorry for typing so fast. So so now you have transport over here, and now it's gonna say, hey, transport .car is not a member of transport anymore, because it's things that you're referring to this one, right? And let's say that you had reasons not to rename this one. What you can do is you can rename it over here. You can do an arrow to the right, and then you can say, for example, I don't know, machines, right? So now you can do machines.car, and you can have both, right? So you can have your transport and you can have your machines.car. What you can also do is you can sort of remove things from the import. So you can say, for example, okay, I want to import transport, and I want to rename it to machines, and I also want to import animals, but I specifically don't want to import plants, right? For some reason, right? You can say like this, you just give it an underscore as a name. So right now, plants is not accessible. Now, in this case, it's actually a bad example, because in this case, you're only importing transport and animals anyway, right? So the plants are not imported anyway. But this one is a better one, right? So you can say, don't import plants, import transport and rename it to machines, and import literally everything else except for plants, right? So import everything else, but not plants, right? So if I save this file, it's still going to say, hey, plants don't exist. Right, but if I comment this out, then it's gonna work. There's also a convenient syntax to import like literally everything that we've also probably seen in my previous videos, but we haven't really talked about imports. It's over here. It's basically an underscore. Machines doesn't exist anymore now, so now we can have transport over here and remove this. So this thing is called an on-demand import. Sometimes it's also called wildcard import, and there's also a better syntax for this like that. Now, you might be overwhelmed with this whole flexibility, so as sort of a guide, I will tell you to always use underscore as soon as you have more than one import. Now, this opinion is usually frowned up in the industry. It's usually recommended to use very explicit imports, to import only the things that you actually need. But I said it before, I'm going to say it again. If you make something that convenient, don't be surprised if everyone's going to use it. It's just so convenient to just import underscore, especially when you start moving things around. If you have those explicit imports, you will have to go there and you will have to change them. With the underscore, you're gonna have a better luck. You will have other problems though. One other thing to note is that, importing underscore is technically a little bit slower to compile, right? Because the compiler has to go through many more options now to find the identifiers that you're looking for. But it doesn't have any access. It doesn't have any effect on the actual runtime performance. It's only the compilation that is slower, and also it's kind of marginally slow. I don't have any numbers to prove this, but these are not the things that actually slow the compilation down so much that you will notice it. Also, IDEs help a lot with the import. So essentially what they will do is that, if you start typing something like transport, it's going to say like, hey, transport, I can't find transport, but I think it's in the package, words nows. Do you want to import it? And then it will import it for you. You can also format them and group them so nicely and whatnot, right? Essentially, agree on something with your team on the style that you're using, and then just follow it and never have this discussion again. All right, so we're almost done with the entire video. I just want to stress that in Scala, you can import literally everything, even vars. Let me show you this. So let's say that you have a person, right, which you shouldn't probably have, and you have a var age, right, so the person can get older, right? So over here what you can do is you can say val p equals new person, right, and you say it's the age is like 27, right? So over here you can import p.age, right, and I can say age equals 28, and now you can print out p.age and it will be 28, right? So you're actually importing this. So it's a bit kind of confusing. Like all of a sudden you see like this assignment to this variable, and this variable kind of doesn't exist, and you're modifying something inside of the person, so it's a bit confusing. But at the same time you kind of have to admit that it's actually also really cool, right? I can imagine that you can write like insanely confusing DSLs with it. All right, so let me remove that real quick, and one of the last things that we're going to talk about are the so-called implicit imports, which I believe is a bad name because there's also a concept called implicit in Scala. So what I'm going to call them is automatic imports. So every file that you have in Scala automatically imports three things. It imports everything from Java-Lang, right? It imports everything from Scala, and it imports everything from an object called predef. Right, like this. In fact, this is going to compile. And also notice that because we're importing Scala and predef is inside of Scala, we could also do this, right? We could do scala.predef, right? But because we already imported Scala, we don't have to do this, right? So I'm going to leave them over here for a second, but by the end I'm going to remove them. So I'm going to show you a bunch of code that is going to just compile, and then I'm going to remove these, and then you're going to see that it's still going to compile. So this is going to prove the point that they are always in scope. I don't believe that we need these anymore, but still, let me just comment them out. Right, so the print line itself, right? So every time you say print line hi, you're actually seeing predef dot print line hi, and this is also predef, right? And again, this is also the same as scala dot predef dot print line hi, right? So all of these are gonna work if I type them right. What's happening today, right? So we're gonna have Scala predef, right? And by the way, if you look at the implementation of predef println, what you will see is that it's actually just delegated into console println, right? So this is the same thing, and console is in Scala console println hi, right? So let me, for example, remove all of these imports, and you're gonna see that it still compiles, right? In fact, I'm gonna remove them completely now. Right? Okay, so let me just gonna have like a few more examples. Remember this from the previous video, the method called require that is going to throw an exception if you pass it a boolean that is false. It is actually defined in predef, right? So predef require true, same thing as scala.predef dot require true, right? So all of this, they're not going to throw an exception because we're passing in actually a true. The next thing is going to be from Java-Lang, so we can have an a string, which is a hi. We're going to have a b, which is a Java-Lang string, which is a hi, and also we could have a c, which is going to infer the type somehow, right? So if we do this, and now we can, for example, we can print line a.getClass. Let me scroll down a bit, b.getClass and c.getClass, and they all are going to be saying Java long string, right? So it's all the same, right? And the last one that we're going to have is the annotation. So remember we talked about tail recursion, right? So we can have at Scala annotation dot tail rec, and the same thing we could have with def y and equals y. We could do annotation dot tail rec. Just agree with on a style with your team and do one of these. So we're gonna get like those two warnings, right? That we're not actually using x, and we don't have an endless loop because we're not actually calling x or y. right? Okay, I believe that's all I got for you today. Actually, before I leave, let me say a few things. Let me actually remove all of this, and let me say a few things like this. There we go. Okay, back to normal. Firstly, it's sort of a convention to use the reverse domain name for your packages. Let me show you an example. For example, Twitter. If we go over here, it has a lot, the company's called Twitter, they have a website called twitter.com. They have a project called Finatra. So what they have is Finatra, and then they have, source, main, Scala, com, Twitter, and then Finatra, right? So their package is com.twitter.finatra.http and so on and so on and so on. So in comparison to in Scala, we also have this convention, right? So notice that this is a Scala file, right? So this is not Java. So this is still a convention that is coming from Java, but you kind of see this tendency in in the Scala community that we don't appreciate it too much. So sometimes we would just call them however we want, and there are reasons for this. First of all, we don't have that many libraries in the Scala world as in the Java world, right? I mean, don't get me wrong, we're still talking about thousands here, right? But not like millions as we have them in Java, right? And the second thing is, because we have those imports where we can rename things, it's sort of a bit of a less of an issue. But still, the big part of the industry is still using this over here, so you should probably do this as well. If you don't have your own company, right? So if you're just a regular person, learning Scala, I'm sure that you have a GitHub account. So what you can do is you can use com.github.your username as a package for your libraries. By the way, notice that this import, I don't know why it's here, but it's kind of useless, right? In fact, I believe that you should also get a warning from this, because we're in exactly the same package where route, index, and request are defined, right? So I don't really understand this. Anyway, let me go back to the second point is that it's a bit of an advanced topic, and I'm going to have a dedicated video about this in the future. So not only can you have multiple files that belong to the same package, you can also have multiple jars and multiple sub-projects that will have exactly the same package, right? So the files will be spread out through multiple jars and through multiple the packages will be spread out through multiple jars, and the files are going to be spread out in multiple jars. I didn't show you it here because it's a bit of an advanced topic, because you can actually run into some really nasty issues, and as I already said, we're going to have dedicated videos about this in the future. So for now, you have your empty scopes, and you have your val, staffs, wires, and whatnot. Then you have your classes, objects, and traits, and then you have packages, and that's basically it. In fact, again, it's a bit of an advanced topic. In Java 9, was a project Jigsaw. You will also have something on top of packages called modules, and we're going to have dedicated videos about this in the future. The third thing that I will mention is that packages and imports are a very, very important topic. If you don't treat them with respect, you sort of miss an opportunity of a very valuable insight. Look at this. If you have packages, it doesn't matter which style you use, if you use the chain clauses or not. So if you have, for example, package com.twitter, right, and you can have package project name, right, and if you have project, feature name, what did I say, project feature name? I meant package feature name, right? And then you have, let's say package sub feature name, right? Then as soon as you see something like this, import other feature name dot underscore or something, right? You see right here and there, that you have a dependency on another feature, right? So this feature has a dependency on another feature. So if you don't really care, where you put things, if you don't structure your application properly, or if you let your IDE just manage the imports for you, right? Because why should you care, right? If you can just click a shortcut on your IDE and it will just import the thing that you need, right? And then you're gonna end up with having 40, 50 imports. Why should you even care? Well, because you're gonna miss the opportunity of this very valuable insight, right? To see at a first glance what depends on what in your entire big system, because this happens a lot, right? So you start as a new company, you get this gigantic new code base thrown at you, right? Wouldn't it be awesome if you just open a random file and you see something like this? Okay, I'm in this feature, I'm in this sub feature, but this feature or depends on this feature. So already you have in your head this mental picture of this this mind map, right? That okay, this feature has a dependency on that feature, instead of digging through 40 different imports, right? So only the fact that IDE manage them for you is not necessarily a sign that you should allow them to do so. All right, it's been Vlad, devinside.com. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.